data types in C. Any variable or a data, it should be declared before you use it in a program. And these data types are the keywords which are used for assigning a type to a variable. We shall now look at the different types of data types. When you look at the types of data types, they are fundamentally classified into two types. One is a fundamental data type and the other is a derived data type. And under your fundamental data types, you'll have integer data type, which is used for storing a whole number. And secondly, you will have a floating point data type, which is used for storing a number with a decimal part. And third is a character data type, which is used for storing any character. And under your derived data types, you'll have arrays, pointers, structures and enumeration. How do you declare a variable now? When you look at the syntax for declaring a variable name should be preceded with a data type. So the first thing, we'll have a data type and next you'll have a valid variable name. And this is the syntax for declaring a variable. When you name a variable, you'll have to follow certain conditions. The first rule is that any variable name, it should start with a alphabet. A variable name cannot begin with a number. A variable name should start with the alphabet. That is the first rule. And no special characters are allowed. Special characters like a dot, a comma, a semicolon are not allowed in a variable. The only special character that is allowed in a variable name is a underscore in a variable name. And these are the rules for naming any variable. And followed by, next you will have a data type, and this data type can be any one of the four valid data type. So we shall now look at the first example. The first example, we have a variable called as var1, and this variable is a variable of integer type. So that is how we have declared it as int var1. So this, when I write it to be int, which means that this variable var1 can store any whole number. And when you talk about the size of this variable, generally we say that the size of an integer variable is 2 bytes, but this size will always depend on the system. So we always have an assumption, or we start with an assumption that the size of an integer variable is 2 bytes. Point data type is used to store a decimal number. A decimal number will have a fractional part. For example for decimal numbers will be 2.34 minus 9.382, and also 2.004 is also a decimal number. To store these kinds of decimal numbers, we have two data types in C language. One is a float data type, another is called as a double data type. When you look at an example, the first example stores a variable var2, which is a variable of floating point data type. The second example, var3, is a variable of the type double. So these are the two data types in which you can store a decimal value in C. What is a difference between a floating point and a double data type? Float and double both are used to store a decimal number. So what is the difference between a float and the double? When you look at the size of a floating point data type, it is 4 bytes, and the size of a double data types is 8 bytes. So this is the difference with respect to the size of the data type. And the next difference between these two data types with respect to its precision will be A floating point variable has a precision of 6 digits, whereas a double variable precision is of 14 digits. So this is a difference between a float and a double. So which means that when you have to store a small float decimal number, we use a float data type, and for a bigger decimal value you use a double data type. And the next data type we'll be discussing is a character data type. The keyword that you use is char, and this is used for declaring the variable of character type. For example, I have a variable here called as var4, which is of the type char, and this stores a value of h, and any value when you store it as a character data type, it should be given within a single quotes. So now the size of a character variable is 1 byte, and this character data type consists of ASCII character, where in ASCII characters each and every alphabet will have a value assigned to it. For example, small a will have a value of 97, and small b will have a value of 98, capital A will have a value of 65, ampersand will have a value of 33, and number 2 will have a value of 49. So in this declaration, var4 is equal to h, and this variable will contain the ASCII value of h. So we shall be discussing about your type qualifiers. So these type qualifiers alters the meaning of the basic data types to yield a new data type. So the first type qualifiers we will see is with respect to a size qualifiers, and these size qualifiers alters the size of basic data type. There are two type qualifiers, which is the first is long and the second is short. When I say a variable, when I declare a variable to be long int I, which means that the size of this variable or the size of this integer variable will become either 4 or 8 bytes depending upon the system architecture. When you don't require a longer memory space, then you will use the keyword called as short. And the next qualifiers will be your sign qualifiers. Sign qualifier will decide whether a variable can hold a positive value or a negative value, or it can hold both positive and negative values. So you have two sign qualifiers. The first is sign and the second is unsigned qualifiers. For example, when I declare a variable to be unsigned, it means that this variable can hold either 0 and only positive numbers. By default, all the variables are signed, and sign qualifiers can be applied to only integer and character data types. We will be discussing is the constant qualifiers, and when you declare a constant qualifier, it is declared with a keyword const, and any variable which is declared as a constant, it cannot be modified in a program. For example, here I have an integer variable p which is assigned a value of 20, and this integer variable p is declared as a constant using the constant qualifiers, and which means that the value of p cannot be changed in a program, and when you try to change this value of p within your program, you will be getting an error. And the next data type is called as user defined data types. So you'll have two user defined data types. The first one is called as your type def and second is called as your enumeration. So we shall now see the first user defined data type, which is type def. So this type def is used to give a new name to an existing data type. Remember, we are not creating a new data type here, but we are giving a new name to an existing data type. So why do you use this type def? So this is used to enhance the readability of a program. For declaring a type def is a keyword, and next you'll have a type. This is one of the valid data type. It can be an integer, it can be a character, it can be a float, or it can be a double. And next is the new name that you are giving to your data type. So we shall now look at an example for type def. So this is an example here. So we have the keyword type def, and next is an int. This is an existing or a old data type, and next you will have length. Length is the new data type that you are creating, right? So the next line I have length. Length is the data type here, and it has three variables: length, width and height. So this declaration, length is your new data type now, and it has three variables: length, width and height. So this statement is equivalent to int length, width and height. Create length is not a new data type that is created. Length is the new name that is given to your existing data type int. So this is your type def, and the next user defined data type is called as your enumerated data type, right? So this is in short written as enum. So when you look at the difference between an enum and a type def, in enum we will be specifying the list of values or the list of values that your enum can take, but in type def we don't. Enum is the second user defined data type. In enum we give the list of names or a list of values that your data type can take. So this is your syntax for an enumerated data type. We have the keyword enum followed by the name of the enumerated data type, the list of the values it can take, followed by the list of the variables. As an example, enum is a keyword, then month is the name of the new enumerated data type that you create, and this is your line 1 of your declaration. And in your second line you have the 12 months of the year. January, February, March, April, May are the list of values that your month can take. And in the third line you are declaring a enum variable list. So our month. So now enum is a keyword and month is the name of the new enumerated data type, and our month is the variable that you are creating for an enumerated data type. So now when I say our month is equal to Feb, which means that in an enumerated data type every values will have a numeric value assigned to it. For example, here by default January has a value of 0, February has a value of 1, March has a value of 2, April has a value of 3 and so on. So when I say here, when I try to print off the value of our month, the value that gets displayed to me will be 1. So we shall now see some example questions. Real constant in C can be expressed in which of the following forms? Option A, fraction form. Option B, exponential form. option C ASCII form, and option D both fractional and exponential form. And the answer for this is it can be expressed both in fractional and exponential form, so the answer is option D. So the second question, a character variable can at a time store, first option is one character, B 8, C 254, D none of the above. The option A is the right answer. It can store one character at a time. The third question, the statement character CH is equal to Z would store in CH. The first option, the character Z, B ASCII value of Z, C Z along with the single inverted commas, and D both A and B. You know that when you declare a variable to be a character variable, it stores the ASCII value. So the answer for that is option B, where the ASCII value of Z will be stored in CH. And the next question, if A is an integer variable, A is equal to 5 divided by 2 will return a value. Option A is 2.5, option B is 3, option C 2, option D 0. 5 divided by 2 is equal to 2.5. So A will be equal to 2.5, but remember that A is stored as an integer variable, so the decimal part gets truncated automatically, so A will store a value of 2. So the right answer is option C. So we'll move on to the next question. What will be the output of the following program? We have a C code here. I've declared an integer variable I, and I have a for loop here, and this for loop runs from I is equal to 0 to I less than or equal to 50,000, and the value of I is incremented, and I'll be printing the value of I. So what will be the output of this program? So now we shall look at the output of this program. It says that the program gets stuck in an infinite loop. Why is this so? This is because here 50,000 exceeds the range, the maximum range of an integer variable. So we'll now move on to the next question. Here again I have a program here. Float A is equal to 13.5, double B is equal to 13.5, and now when in my printf statement I use the format specifiers as %f for floating point and %lf for long floating point, and using this I display the value of A and B. So what will be the output of this program? Let's look at the output for this program. It's 13.5 0000 and 13.5 000. So this is the output for this program. So we shall move on to the next program now. What will be the value of D? Assume D to be float. After the operation, D is equal to 2 divided by 7.0. The options are option A 0, option B 0.2857, option C cannot be determined, option D none. So let's now look at the answer. So it's option B 0.2857 will be the value of D, since D declared to be a floating point data type. So the next question, consider the following declarations of enum. So here you have 4 declarations of enum, and the first declaration enum is the keyword, cricket is the name of the enumerated data type, and you have 3 value followed by the a C, which is called as a enum variable. And in the second option you have the keyword enum, the name of the enumerated data type, values without a enumerated variable here. And the third one, enum is the keyword, then you have the names, and where the second name you have assigned a value, and you have again C here. The fourth option, enum is the keyword, and here you don't have a name. This C will be the name of this enumerated data type followed by the variables. So out of these 4 declaration of enum, which is the correct declaration? The first option says only option 1 is correct. The second option says 1 and 2 are correct. Option C, 1 and 3 are correct. Option D, 1, 2 and 3 are right. And the last option says that all the 4 declarations are valid declaration. So what will be the answer? So now let's look at the answer, so which is option E. So which means that all the 4 declarations of enum are valid. So we shall move on to the next question. What will be the output of this following C program? So here I have a variable num, which is of the type double, which is equal to 5.2, an integer variable with a value of 5, and here in my printf statement I am printing the size of this double variable here. Second printf, I am printing the size of the integer variable, which is equal to 15 divided by 2, and the third printf, I am printing the variable, I am printing the integer variable. So we shall now look at the options. The first options is 4, 2, 7, option B 4, 4, 5, option C 2, 2, 5, and option D is 2, 4, 7. So what will be the output? Which of these options are right? So now let's look at the output, which is option C, which says 2, 2, 5. So how do I get this output 2, 2, 5? Get this output of 2, 2, 5, which means that the first printf has displayed a value of 2, the second printf has displayed the value of 2, and again the third printf has displayed the value of 5. So how is this? The first printf, I say size of not of now. So this will be size of not of 5.2. So which evaluates to 0. 0 is an integer constant. So this size of this integer constant is 2. So the first printf displays a value of 2, and in the second printf its size of variable is equal to 15 divided by 2, which is again an integer. So the size of an integer is 2. So the second printf also displays me a value of 2. And now when you move to the third printf, which prints the variable var, I'll be printing only the initial value of this variable 5, because any modification of a size, any modification of this variable here will be within the scope of this size of operator. So now the third printf, when I print the value of this var, I'll be printing only its initial value, which is 5. So this is the reason why I get my option C as the right answer. So we shall move on to the next question. So what will be the output of this program? So I have an constant integer p and an integer a is equal to 10, and this p stores the address of a. Now I print the value of p. So we shall now look at the options. Option A has a value of 0, option B has a value of 10, option C garbage value, option D error. So which will be the right option? So we shall now look at the answer for this question. So it will be option B, 10. So how do I get this 10 as my answer? Right? So this is your program, right? So A is equal to 10. So this P stores the address of 10, right? P stores the address of 10. So now here when I print, what is this represent, what is the value at that address? So 10 will be displayed to be as the answer. So the right answer will be option B, which is 10. So we shall now move on to the next question. So what is the output of this program? Here I have an integer variable a is equal to 11, volatile, and this integer has been assigned with a prefix volatile, and now I am printing the value of this a. So we shall now look at the options here. A is 11, B is garbage, C cannot predict, and D is compilation error. So these are the options. So what will be the right option here? So we shall now look at the output. It's answer C, we cannot predict, because volatile is something which keeps on changing. So the next question, what is the range of assigned integer data type in that compiler in which the size of an integer is 2 bytes? So what is the range of assigned integer data type? You have 4 options here. So which are the right option? So we shall now look at the answer. So option D is the right answer. So we shall now move on to the next question. 13. Which of the following is not a derived data type in C? First option, option A is function, option B pointer, option C enumeration, option D array, and option E all or derived data type. So we shall now look at the answer. The option C is the right answer. So enumeration is not a derived data type in C.